Alright guys, so it's been a while, yeah. I'm very sorry. Something that happened don't make me to make video for a while. Yeah. You're welcome again to my channel. So, you know, we solve our beautiful problems in this channel. Yeah, and then today we have a beautiful equation right there. It's a transcendental equation. So we have to find the integer value of x that satisfies the equation below. 2 raised to the power of x plus x equals 3. That's what I want to do. So we want to find the integer value of x. Though there's other value of x that's not an integer, that's a decimal. Okay, we have that also. But in today's video, what we're focusing on is just the integer value of x. Okay, maybe in my next video I'm gonna solve for the other value of x using the other method. Alright, so if you're new to this channel, please don't forget to subscribe, like, comment, and also share, and click the notification button so that anytime we upload video you'll be the first to watch. Alright guys, let's dive into the solution. So the first thing I'm gonna do now is to make a beautiful substitution. So what kind of substitution I'm making? So we can say let this 2 raised to the power of x, okay, so be equal to any variable you want to be using. So let's use lambda. Yeah, I love using lambda a lot, so let's make use of lambda. Yeah, so next thing you're going to do now is to make x the subject of the formula over there. So and how do you do that? You have to take the natural log of both sides. So take the natural log of 2 raised to the power of x equals natural log of lambda. I create a lot of indices, so this x will come out of the inside from the bracket. So we're gonna have x multiplied by natural log of 2 equals natural log of lambda. And remember, we want to make x the subject of the formula, so what you're gonna do now is to divide through by natural log of 2. So we do that, we have x equals natural log of lambda over natural log of 2. That's actually beautiful. That's cool. That's cool. So what the next thing we're going to do now is to substitute what we've just find into this equation. 2 raised to the power of x is lambda, and x is now natural log of lambda over natural log of 2. So that's what we're going to do now. Yeah, I hope we're ready. Oh my god, now let's do that. Let's do this. Let's do that. So instead of us writing 2 raised to the power of x, we write lambda plus, so instead of you writing x, you have a natural log of lambda over natural log of 2, then everything will be equal to 3. What is the next thing we're gonna do? This is a natural log of 2, so I don't want it there, so I want to eradicate this natural log of 2 from the denominator. So what do you think we can do? That is to eradicate fractions, so you have to multiply both sides by the denominator, which is natural log of 2. Then if you do that, we're going to have lambda multiplied by natural log of 2, then plus natural log of lambda equals 3 multiplied by natural log of 2. That's actually cool. That's cool. And then don't forget 3 natural log of 2, it means 8, because a lot of indices, if you let me use another marker here. If you have b natural log of a, it means natural log of a raised to the power of b. So that's what happened here. So 3 natural log of 2, it means natural log of 2 raised to the power of 3, which is 8. Okay, so we can now rewrite this as lambda multiplied by natural log of 2 plus natural log of lambda equals natural log of 8. That's actually cool. So what is the next thing that we're gonna do now? Yeah, so next thing we're gonna do is to subtract lambda ln 2 from both sides. So even though that we're gonna have natural log of lambda, so this will be equal to natural log of 8, then minus lambda natural log of 2. All right, so the next thing we're gonna do is to raise both, like you raise e to the both equation right here. That is the base of this natural log is e. Then if you do that, we're gonna have e raised to the power of natural log of lambda equals e raised to the power of natural log of 8, then a minus lambda natural log of 2. That's actually cool. Yeah, so e raised to the power of natural log of lambda, so definitely that should give us lambda. And if you apply the law of indices right here, so you're going to have e raised to the power of natural log of 8, then multiply by e raised to the power of negative lambda multiplied by natural log of 2, and then e raised to the power of natural log of 8. So definitely that should give us 8. So we're going to have lambda equal to 8, then multiply by, so e raised to the power of let me just leave that for now. E raised to the power of negative lambda ln 2. Yeah, that's cool. So that's cool. So next thing we're gonna do, you can see this is lambda right here, this is also lambda right here. So what can I do to bring the two together? So what we're gonna do now is to multiply both sides by e. You multiply through by e raised to the power of lambda ln 2. So we do that, so we're gonna have the following. So lambda multiplied by e raised to the power of lambda ln 2, that will surely give us lambda e raised to the power of lambda ln 2. So which is equal to 8, then I multiply by, so e raised to the power of negative lambda ln 2 multiplied by e raised to the power of lambda ln 2. You know, this is negative and this is positive, then if we add, that surely give us 0. And then e raised to the power of 0, that is 1. So that is actually beautiful. That's beautiful. All right, my people, well, we are almost done solving the problem. So what is the next thing you think we're gonna do? Yeah, I'm going to write down something that is very, very important. The property and that we are using this morning is still hidden, but I'm gonna decode it now, which is the Lambert W function. You some call it product log. So what does it say now? If you have this kind of function, if you have alpha e raised to the power of alpha, then you take the Lambert W function of this, so this will surely give you alpha. You get what I'm saying now? That surely give you alpha. So what do you think you can do now to make what is here to be the same what is here? If you check here, we have natural log of 2, and here we don't have natural log of 2. So what do you think we can do? So what we're gonna do now is to multiply through by natural log of 2. All right, so if we do that, we have lambda multiplied by natural log of 2, then multiply by e raised to the power of lambda natural log of 2, so which is actually equal to 8 multiplied by natural log of 2. Remember, why did I do that? You know, what you do to the, whatever you do to the left hand side definitely must be done also to the left, to the right hand side. You know, don't forget 8 means 4 multiplied by 2. So I can write this as lambda multiplied by natural log of 2 multiplied by e raised to the power of natural log of 2. So this is equal to 4, then multiplied by 2 natural log of 2, because 4 times 2 surely gives us 8. Then we can now rewrite these as ln 4, because 2 ln 2 means ln 2 raised to the power of 2, which is ln 4. So we're gonna have lambda ln 2, then multiply by e raised to the power of lambda ln 2. So this will be equal to 4 multiplied by ln 4. Yeah, so we can now take the lambda w function of both sides. So guys, let's do that. So we do that, we have lambda w function of lambda multiplied by natural log of 2, then multiplied by e raised to the power of lambda multiplied by natural log of 2. So which is equal to, lambda w function of 4 multiplied by natural log of 4. So what I notice of this and this way, surely cancel out, we have lambda multiplied by natural log of 2 equals, and then remember, if we have the lambda w function of e ln a, so this will surely give us ln a. Yeah, so that's all gonna give us. Yeah, so that will give you ln a. So let's move on, and then so lambda w function of 4 ln 4, so that will surely give us ln 4. So we have multiplied by ln 4, though you divide through by ln 2, so ln 2 we cancel out ln 2, so we have lambda equals, so don't forget ln 4 means 2 ln 2, then over this ln 2, so ln 2 we cancel out ln 2, so the value of lambda is 2. But remember, we now have to find lambda. What we have to find is x. But from the first statement here, I said let 2 raised to the power of x be equal to lambda, so we cannot find the value of x from that. So we have 2 raised to the power of x is equal to lambda, and we know the value of lambda, which is 2. So we have 2 raised to the power of x equals 2 raised to the power of 1. Alright, then if you equate the exponents, so we have x is equal to big 1. Yeah, so that's the answer to the beautiful problem. Alright guys, so if you like this kind of video, please don't forget to subscribe to my channel, like my videos, comment, and also share, and click the notification button so that anytime we upload video, you'll be the first to watch. Yeah, you be the first one, because you're a very unique person. So oh my god. All right guys, so let's meet another time. See you next time.